Welcome back, Dave.
Yes.
Glad to be here.
Why don't you let us know what we're gonna dig into here today?
Sure. So my name is Dave Beckberg. I'm a senior graph architect on the Amazon Neptune team. For those of you that are not familiar with what Neptune is, Neptune is AWS's purpose-built database offering for graph databases. And what we're going to be kind of showing today is actually a very new tool that we just introduced. It was actually the very beginning of this month. So it's open source. We call it Graph Explorer, and it's a open source, low code visual exploration tool for looking at your graph data stored inside Neptune or other open standard graph databases. So really kind of excited to kind of jump right in and kind of show you guys what we have. But I think there's probably at least a set of your customers here that are probably not quite familiar with what graphs or graph databases are. So figured it might be good to ask, kind of give a little bit of background on what those are.
I think so, right? I'm in that group too. I've read the blogs. I understand it conceptually, right? But I've never had to use it. So would love let's set the foundation here before we show them the tool.
Absolutely. I mean, so my background, I've worked in software for like 25 years at this point, and the last 8 working kind of with graphs very, very deeply. So I've answered this question for a lot of people because it's kind of, it's a new technology out there, especially kind of as databases go. But what graphs are, or what graph databases are, is graph databases it's a type of database. And in AWS, it's the database is Amazon Neptune. And it's really built for dealing with highly connected data and the types of questions where you want to be able to look at that data and move across those connections in such a way that you're able to answer questions very efficiently and effectively. Kind of if you want to look at like the canonical graph use case would be something like a social network. Inside a social network, typical sort of thing you would have questions of like, who are my friends or who are the friends of my friends? Those are the sorts of questions that you kind of see people talk about graph databases a lot. And you can definitely put that sort of information in a graph database where you're representing people as nodes in graph terms, and the connections between them as relationships, or maybe it's a nose edge or a friend's edge if you want to think about it in terms of like how Twitter works or Facebook and LinkedIn sort of works. And graphs are very efficient at being able to use those nodes and connections between things to answer specific types of questions where those sorts of things become very important and relevant. For example, how, what is, I use the example of friends of friends. That's something you could do in a graph database. It's also something you could kind of do in a relational database. It's just two database joins. But if you wanted to answer questions like how are Trevor and I, connected on LinkedIn, or how are we connected on Twitter, that's one that's not as easy to answer in kind of more traditional database technologies, because you don't know how many connections it is. It might be one, we might be directly connected, we might not be connected at all, or we might be connected through some kind of very circuitous route, for lack of a better term. And those are the sorts of questions where graph databases, because of the nature of actually, the math that's underpinning them, as well as how we store the data, makes it very efficient to answer those sorts of questions.
That makes a lot of sense to me. So instead of doing like multiple different queries across databases to find something, you can more efficiently make queries for these kind of complex relationships. And that social network example. Okay.
Social networking is an example. We kind of have 4 main use cases that we work with customers on. The first one being kind of identity graphs, or, you have somebody coming in from their home website, their work website, their phone, their iPad, and trying to kind of take all of this activity that somebody's doing and uniquely kind of identify that down into a single type of person. Second one is a very common, kind of another really common one, which is actually what kind of we'll be demoing a little bit here in a moment, is fraud graphs, looking at how, fraud by its very nature is really, especially when you start talking about things like identification of fraud rings, it's really about looking at how things are connected together and how closely or far things are connected together, and using that to kind of provide some level of risking or risk analysis on top of your data. To speak to the security information that we kind of have out there, one of our actually really common ones, and some of our bigger customers, what we call security graphs. So the security graphs are kind of a very wide thing. But it's one of those sorts of things. A security graph, for example, could be give me a graph that represents how all of my AWS infrastructure is connected together. And actually, some of our very large customers are doing exactly that on top of Neptune. Wiz.io would be one that you can kind of look up. They've spoken with us at several of the things about how they're using Neptune to power their sorts of cloud posture management tools. And then the last one is kind of we call it knowledge graphs, which is really the ability to connect data from different data silos. But I also kind of think of it as a little bit of a catch-all term, sort of like machine learning or AI, where when you're not 100% sure where your problem fits into those other sorts of ones, it's sort of the one everyone talks about. But those are commonly used for things like customer 360 type use cases, know your customer things you've probably heard, either people, people watching this have seen, or people that have talked to other people that are trying to build those sorts of solutions.
It's so fascinating learning about graph databases, and we've got a lot of people who are in the chat and they're new to graph databases too. So Dave, a question that came up that maybe you can clarify, especially for the people who are really new, and this was from Gifted Greedy, which I think the intention of the question is really on like what kind of data can be stored, and maybe a little bit of a brief clarification on like the graphs part of the graph database.
So when you're speaking about graph in the graph part of the database, what you're actually speaking about is not so much when you think about graphs in terms of bar charts or line charts or anything like that. It's graph theory. It's the mathematical underpinnings of how you work with data. So if you think about a relational database, all relational databases are based on relational algebra and set theory. That's really the math that backs those up. Graph databases are based on graph theory, which is a branch of mathematics that basically deals with highly connected types of data. You may have heard of the 7 bridges of Königsberg problem. That's sort of by Euler. That's kind of the historical foundation of graph theory and how that evolved. So yeah, when we're talking about graphs, it's not so much charts or bar charts. It's actually the underlying math that you use to be able to answer these sorts of questions efficiently and effectively. And graphs are something that as developers, we all use all day. We may not know it, but we're using this. I mean, trees, linked lists, all those sorts of things are a graph data structure. Like they are a graph data structure. You may not have thought of them as a graph data structure, but they are. Dealing with breadth first search or depth first search type of problems are very classical graph mathematical, or graph theory, graph mathematical constructs.
Okay, well, I'm looking forward to seeing it. For me, I think I'm a visual learner, so when I've been seeing this kind of in the background here. So let's take a look at this new tool.
Yeah. So yeah, this is the tool we're looking at here. Is actually I kind of I did what I call like a Julia Childs. I kind of pre-built something, take it out of the oven so I can start with the picture, and then we'll walk backwards on how to actually build this sort of thing out. But without me even really giving you any context here, I think you can start to see some of the power of this sort of exploration tool, being able to actually just physically look at my data. How is my data connected? You can probably look at this and see that things are, as I said, this is fraud data that we're looking at here. So we're looking at, people or accounts that have purchased things, and there's certain attributes about them. There's, IP addresses associated with a purchase, phone numbers, email addresses, shipping addresses, the kind of standard things you would think about if you wanted to think about, purchasing something on Amazon.com or something like that, the sort of information you would be collecting there. And what we're doing here is this is our visualization, our open source visualization tool that we're able to do with this. So, even without, like I said, without giving you any kind of context, you can start to see that there may be, because we're able to look at this visually, we start to see there may be some kind of awkward things going on here. For example, why is this user and this user, why are they sharing an email address and a phone and a computer? This starts to seem things where you might start looking at this, and it might start help to drive the sorts of analysis or business questions you want to use. So kind of how did we get here? Well, as we mentioned, graph databases, there's kind of a fundamentally built on some other tooling and information that we have. But one of the key things when we were talking to customers that they were asking for was really when you're getting started, or even if you have someone that maybe not as technical as some developers or something, they want to be able to actually look at this data. They want to be able to touch the data. They want to be able to manipulate the data and look at how these different connections may feed together. But they want to do this without having to go through the entire process of learning new query languages or new interfaces or things to use. And that's really where this tool was built. Was really kind of designed and optimized for, which is that low code visual exploration of your data. I want to start at a place and start to look out from there and see how things are done. So we did that by kind of building out a faceted search type capability. So this tool, as I mentioned, it's an open source tool. It's actually available. We have it built as a Docker image. So you can basically load this data. You can basically get this from GitHub. You can build the Docker image, and then you can run it on ECS, or you could run it in Fargate. I'm personally running here on a small EC2 instance running Docker. And basically you can use this to connect to Amazon Neptune or any of the other kind of open standards databases out there that support either Tinkerpop Gremlin or Sparkle, which are two standard query languages out in the graph world. But what I can do here, when I want to get started here, is I can come into this and start doing this sort of faceted search sort of thing. So if we came in here, I happen to know that there's an account in here with a number of 1937, just to so everyone knows where that came from. But if you wanted to think about this in terms of a more realistic use case, maybe you're a fraud analyst and you've gotten this, either a transaction that was reported as suspicious or an account got flagged as a fraudulent account. Well, I want to start to see how that is related to other things inside my graph. Start look for things that may be potential patterns of fraud. So I can come in here, and as I said, I can come in here and I can kind of just type in something, and it will go out and create basically perform a search against the database. In this case, I narrowed it down to only search on a specific type of node. So I'm only looking at account nodes in this case. But I can do this, and I can add it right into my the beginning of my exploration. So it kind of gives you that place to give you a starting location for that type of exploration. And then kind of the big things you can do from there is this: you can actually go out and do exploration. So I can double click on this and fetch what's kind of, we in the graph world, we call it the first neighborhood. So basically everything that's connected to that initial node. You can do that, and then you can kind of keep going out from there and expand this out into a variety of different areas and different things.
So Dave, without a tool like this, like you would really need to know the query language behind this database, right? So this really makes it much more accessible for somebody like a cyber fraud agent in this example, right? To be able to parse this data. Wow.
Yeah,
okay.
a business analyst, a cyber fraud analyst. I mean, so we have a variety of other tooling out there that's more focused towards the developers to help them write their queries and visualize those results. But if you don't want to learn the query languages, or if you just want to see what does my data look like, what does this look like? I don't want to necessarily have to write all of these queries in order to do that. So having this sort of tooling was a kind of a very key request that customers had to do that. We also, in addition to just being able to, look at data, we can also click on things, and you can basically look at the individual attributes associated with this. So you can look at the attribute associated with, in this case, I'm looking at an account. You can look at the attributes associated with edges. One of the unique aspects of at least the labeled property graph model, which is one of the two models that Neptune supports, is, you can actually have properties associated not only with entities or the nodes, so the accounts, the phone numbers. You can have properties associated with the edges or the connections between the data. So if you wanted to think about this as something like, if you had a graph here where somebody purchased something, maybe on this purchased edge or this transaction edge, you would have things like, here's the date, here's the time, here's additional information that's really associated with that, essentially that action or that connection instead of the entity itself.
Dave, we got a great question in the chat. So basically, is a graph database a good use case only for answering exploratory questions?
No. So graph databases are actually good for answering any sorts of questions, either exploratory or like transactional for a website, for those types of questions where you need to deal with a lot of the where you can answer that question best by using the connections between the data. So usually we kind of talk about it is where you have something where you need to deal with essentially the existence of connection. Because these two things are connected, it means something important. How they're connected or the path between them. I want to find out if you're associated with anybody that's within 5 hops, that's a known fraudster within 5 hops or 3 hops, something like that. Because that's going to up your, if you think about it in fraud terminology, it's going to up your risk score for a fraud if you're closely connected to somebody that's fraudster versus like, well, within 10 hops. Yeah, okay, that's fine. So they're good for all of those sorts of questions. I mean, graphs are not the best answer for every sort of question. Relational databases answer those sorts of set questions very, very well. So if you wanted to answer something like, give me the sum of all of the sales for March, well, that's the sort of question where, depending on the data size, you would use something like Athena or Redshift or a relational database to be able to answer those sorts of questions very well. But if you wanted to answer those questions of how are Trevor and I connected, that's not something you're easily going to be able to answer with other technologies. You can do it in a relational database, but it's pretty inefficient if you've ever had to write like common table expressions or something, give you a little like recursive SQL. It's not a lot of fun to write or maintain or make performant. So those sorts of things. But yeah, kind of getting a little bit back to the demo. Some of the things we have here, in addition to being able to just look at this data, we actually allow you to kind of come in here and you can set various properties associated with this. You can look at the different number of connections. In this case, this is connected to 2 different accounts and 4 different transactions. You can also come in here and style it. And this has actually been a very big request from customers, is being able to kind of come in and style this in a way that really makes it starting to be meaningful to you. I've already kind of come in and pre-styled these nodes and edges for you in this case. But, even just being able to associate, this icon with this user or this icon with an account, you pretty much immediately already kind of, without me even having to tell you, kind of got an inclination of what this was representing. And this is something that is actually very, very, very powerful, especially if you want to start using this information to do things like give presentations or put this graphic into some of your presentations. Because one of the features we actually do have here is actually the ability to download this graph. So it'll basically take the image that you've built in the screen here. You can download it. You can include it in a presentation. Maybe you need to present something to your boss or upper management or something like that. It's much nicer to have a very pretty picture that shows off the story for you.
I like it. So Dave, I know we've been seeing a lot of reads right now in these use cases. With this tool, can people write?
As it sits today, this is a read-only tool.
Got it. Okay.
Neptune allows you to write to it for either a bulk loader or through our query languages. Today, this tool is really meant for more of the read type user, the user that wants to be able to kind of go in and analyze the types of data that's there, not so much being able to add additional.
Great. Yeah, is there any more that you want to show us?
I think this was kind of the big parts we wanted to show, is just kind of this new tool. As I mentioned, this is open source, so you can go use this, and it's able to be used against databases that aren't Amazon Neptune too. So anything that complies to those open standards that I mentioned, this tool can connect to and use. So it's really kind of not just about making a tool that's very good for Neptune, but also about being able to kind of broaden this out to the larger audience of people that are interested in graphs or new to graphs, to be able to start using this to visualize your graph and see what your information and data looks like.
Yeah, I mean, I just seeing the visual helped me really understand the kind of underlying technology a lot better. So I could see this, in addition to an analysis tool, just like a learning tool for somebody who really wants to understand the data. Thanks for showing us that, Dave.
Yeah.
I mean, I think a lot of times people use it as well for like I just put a bunch of data in, but I don't 100% know what that data looks like.
Yeah. We've got another question. Other visualizations in that tool?
I mean, it is built for basically visualizing either property graph data or our RDF data is the other type of common graph data model that we support in Neptune. And it supports both of those in an interoperable manner, but it doesn't have kind of other visualizations for any other sort of data sources at this point. But it is an open source tool, and we would love if anybody wanted to contribute. To this. It's the great part about it being open source is we
So yeah, Dave, question for the folks here who are new. They're maybe just getting started. Maybe they have a use case that's like perfect for a graph database, like you were saying, fraud. And you were talking earlier about that it relies on graph theory. So with this tool, do they need to start learning graph theory first and then start using Amazon Neptune? Or does this tool allow them to be able to get started right away? What do you suggest?
I mean, this tool actually, and this tool and graph databases in general don't actually require you to learn graph theory under the covers to be able to actually make sense of any of this. You have to learn, if you want to write and build applications on top of them, you do have to learn the query languages, one of the 3 query languages we support in order to do this. But you don't need to know the underpinnings of how it's processing those from using graph theory. I mean, my background is I actually got a degree in electrical engineering, had never had like a discrete math class. So I kind of learned everything. I learned how to use a graph database and then worked backwards to the math that underpins it. So you definitely don't need to understand graph theory or that in order to be able to, use a graph database to help solve these sorts of problems.
Awesome. I mean, an interesting question that I was curious of as you were explaining that, like, does it help as you're writing queries? Or, I mean, it sounds like you were able to work backwards from the queries and then figure out the theory later. So maybe I just answered my own question.
Well, I don't think knowing graph theory doesn't necessarily mean, I don't think it's necessarily required to understand or to know how to write good queries, but there is a bit of a writing queries for graph databases are a little bit different than writing queries for like a relational database. And the biggest one is, you can kind of think of it theoretically, and this is a drastic oversimplification, but as you're doing joins inside of a relational database, you're basically building a bigger and bigger in-memory table that stores basically the collection or union of all of those different things, union or disjoint, depending on how you write your query, but you're basically getting one big table. Well, with the graph, unless you specifically ask for to kind of keep a reference to things, you're not building a bigger and bigger table. You're moving from location A to location B to location C. So it's able to do that very, very efficiently because you're essentially not carrying all of the baggage with you unless you're explicitly asked for it. So, you can get to the end of your graph traversal, but you aren't necessarily able to fetch things earlier unless you explicitly say, I want to be able to fetch this earlier. And that's kind of one of the advantages that the data structure and the math provides for graphs that are not, that's definitely somewhere that people learn or have to learn in order to be efficient at writing queries.
Yeah, there's one more question. So, I mean, the gist of this question is, I mean, you were talking about fraud as like a security use case, but have you also seen it used for just like permissions or any other types of security internal related use cases?
I mean, so security in general is a high use case, but I mean, as far as this specifically around like mapping user groups and things like that, we actually do have a very large client that is actually using a graph as the fundamental real-time interface that they're checking essentially auth-n and auth-z for their internal customers on, because they have very complex groups of permissions and things of that nature. And being able to kind of quickly and easily say, does this person have access to this is very useful, especially if in their specific case, they have a lot of rules of like, they can access this, but only on the 3rd Tuesday of the month between 7 and 9 p.m. or something like that. So you start building you start building that sort of logic into your workflow. It gets very, very, it can quickly get very complex. And one of the more interesting use cases I've seen in that scenario was actually, often you'll talk about something in graph terms as like, what is the shortest path between it? So what's the shortest set of connections between Trevor and I? And they were actually using it for a similar use case, but they were looking for long paths. They were looking for outliers in the opposite direction of, why does this person have access to this file? Oh, because they're part member of this group that was given access through this, that was given access through this, that was given access through this, to kind of look and identify those anomalies or anomalous things in the data.
Well, Dave, if you can't tell by all the questions that you're getting, there's a lot of love for Dave. Oh, wrong one. Even Gifted Greedy is digging on some Dave. I'm with you. I like Dave too.
Yep.
Dave is good.
I also like Dave.
Dave, you got anything else that you want to cover with everybody before before we send you off to go write queries and analyze interconnected data?
Nope. Other than maybe, if you want to get started with this, you can get, like I said, this is a free open source tool, and we actually have a free trial of Neptune. So you can, get started without having to pay anything for either one of these tools if you're so interested. So really happy to hear your feedback and any, requests or features you might have.
Wow, Dave, thank you so much for today.
Thank you for having me.